them and nobody ever got sick because they were acidic enough. Nothing was growing in there. I'm not suggesting anybody do that, and I can't promise that grocery store pickles are acidic enough to not be in the refrigerator after you open them. Mine certainly get refrigerated. But yeah, it was a good way to preserve food before refrigeration. Alright, so you got the right temperature, the right amount of oxygen, the right pH. The last factor that affects bacterial growth is water availability. You can have the other three right, all perfect, right? You have the right temperature, the right amount of oxygen, the right pH. If the media dries out, they die. Okay? They have to have water just like we do, so they've got to be in a moist environment.
So they're going to hypotonic.
Well, that's part of it, right? You've got to make sure that they're in an environment they can live in. Hypotonic, they can handle.
Water, right?
Right, the water will try to go in, but their cell wall keeps them from bursting.
Right.
That's usually not something we have to worry about. We just have to make sure that the media that they're growing on is still moist. For instance, these little petri dishes, they're good for about a week. More than that, the water starts evaporating out and the agar dries out and becomes a thin little film, like hard plastic almost in here. They're not growing on that. So we don't keep bacteria long term in petri dishes. You know, all of your stock cultures have been in test tubes so far for a reason. They've got little screw cap lids on them. We can keep the liquid inside the tube so they stay moist for longer. They'll live in here for, at high numbers, for a couple of days. Right? They'll start dying off. We're going to talk about that next, what exactly is happening in here. After about a week, there are really low numbers left, but the few that are there can last for months in this tube as long as the lid's on and it stays moist. So if they dry out at all, they're toast. Doesn't matter what you did for the other conditions. Okay, so water is important. They've got to be in a moist environment. So questions on any of those factors that affect growth? Okay. All right, so we're going to move on. If you printed out your handout, we're skipping over to bacterial growth in lab conditions. So, growing bacteria in lab is different than the way they would grow in nature. In nature, they're in what we call an open system. Bacteria in the dirt outside, bacteria on these tables and floors are all in an open system. They have potentially access to lots of food, right? Especially the ones that are out there in the dirt. There's always food around. And their waste can be removed. It's going to go out by diffusion. The rainwater is going to wash it away. And that's an open system. Constant, at least potential supply of food and waste removal. That is not true in these test tubes, these petri dishes that you put in incubators. They don't get a constant source of food, and we're not removing their waste. So that's a closed or batch system. They get a one-time supply of food, only what's in this agar when you made it. One-time supply of food, and their waste is not removed. It has nowhere to go but inside this tube. So that's a closed or batch system. All right. So they grow differently in a closed system than they would in nature. And how they grow, we can represent on a chart called the growth curve. So this is the label for this chart we're about to make here. This graph, X and Y axis here. So we're going to put the number of bacteria on this side. Remember, that's what growth means, increase in number. And time on the x-axis, how long it takes. So when you've got your little loop and you pick up bacteria and you move them into a new tube or to a new petri dish, that's time 0, right? When you first move them over with your loop to the new place.